Okay, now what we want to do is go into section 5.4. We're going to look at section 5.4, part 1 video. And in this particular section here, we're going to continue with polynomials, but we're going to do a little mixture of what we've been doing now. In section 5.3, we looked at how to, in 5.1 and 5.2, we looked at rules of exponents. In 5.3, we looked at adding and subtracting polynomial terms. Now in section 5.4, we're going to look at multiplying polynomials, but we're going to also be doing some adding and subtracting in here as well. So you have to know your rules from section 5.1, 5.2, and 5.3 in order to do these problems. So there's really no new, necessarily anything new that I'll be throwing at you at the beginning of this section anyway. All right, so let's suppose, just for review, let's suppose I had this problem right here. Pause the video and write this down. Okay, so read it to yourself. I'm a big component of that because if you'll read it to yourself, it tells you what you're doing. All right, so listen when I read this. 5x to the third times 7x to the fifth. So we're multiplying this monomial times this monomial. One term times one term. Now, we've already done this. This is just my exponent rules. Because multiplication is commutative, when I multiply that, that's 35x to the 8. Now, can I add those two together? No. But I can multiply them. All right, now, let's look at this one. Pause the video and copy it. Okay, you should have this one copied. All right, so let's read this. This says 2 times, so a monomial, 2 times 3x squared minus 7x plus 4. So you got one term times 3 terms. We give this a special name. Been giving it a special name since about our third or fourth section. We call this the distributive property. Now you say, well, don't we have to do what's in the parentheses first? If you can. But you can't do anything here because this is adding and subtracting, and none of those are like terms. Now let's distribute one term times all 3 of these. So anytime you're doing one term times 2, one term times 3, one term times 4, that's always called the distributive property. Now this is not distributive up here. This is one term times one term. So you just shift it around and multiply the numbers and multiply the letters. This is distributive. So when you distribute that, you get this. And by the way, after you distribute that, you cannot combine any of this together. That's 6x squared minus 14x plus 8, but those are all unlike terms, so that's your answer. But you're still multiplying one polynomial, yes, that's a polynomial, times another polynomial. All right, pause the video and write this next example down. Okay, in this next example, you will see that we're still multiplying a monomial times a trinomial. So this is still the distributive property. But remember, when you multiply, you have to use your multiplying rules. So when you say 5x2 times, and that dot doesn't have to be there, 5x2 times 8x3, that's 40x5, because you have to add your exponents because of the product rule. And then 5x squared times negative 6x is negative 30x3 plus, and then 5x squared times 9 would be 45x squared. And after you distribute that, no, none of those terms are alike, so no, you cannot add or subtract those together. Okay? Pause the video now and copy this next problem down. Okay, so you should have this copied. So this is one term times 3 terms. Now this could have 4, 5, or 6 terms. I'm just stopping at 3. So I'm going to do this times this, this times this, this times this. Now remember, multiplication is commutative. So when you do these two together, that's going to be 18 x squared y 3. When you do these two, it's going to be minus 9 x 3 y. And then when you do this one times this one, it's going to be 12 x 5 y 5. So let me slide this over where you can copy that. That's what you get when you multiply right here. Now, let me say once again, if this had been x2, y3, and this is a x2, y3, I could add those together because they would be like terms. But this one, and this one are all unlike terms, so you cannot add or subtract those together. But always after you distribute, always back up and look and see if any of those terms will add or subtract together. Okay. Now, let's look at this problem right here. So copy this problem down right now. So we've got 3x plus 2 times 5x plus 7. All right, this is the first time in this course that we've looked at a problem like this. All right, first listen to me as I read it. 3x plus 2, binomial, times 5x plus 7. So we've got a binomial times another binomial. Now we have not done that. We have never done that in this course. We've multiplied one term times one term. That's the very first example. One term times 2, one term times 3, one term times 4. But in all your exponent problems we did, it was all one term times one term. So we have never multiplied a polynomial, 2 terms times another polynomial that has 2 terms. Okay, so how do we do this? Well, let me give you the process first and then we'll work it. So here's what I have to do. I have to multiply each term over here times each term over here. So what we're going to do is I'm going to start out with this term and I'm going to multiply this term times both of these. So I'm going to say this times this one, this times this one. Kind of like distributive property, if you will. So I'm going to distribute this with the 3x. And then after I do that, I'm going to do it again, but I'm going to distribute it with the 2 times this one, 2 times this one. So it's this one times both of these, and then this one times both of these. All right, so let's do that. So if I multiply 3x times 5x, careful, that is 15. Make sure this is still, yeah. Okay, so 3x times 5x is 15x2. You add the exponents. But then take 3x times just a 7. That's where this 21x comes from. All right, now when you do that, you're through with this one. Now multiply the 2 times the 5x. That's where this 10x comes from. And then 2 times the plus 7. So a positive 2 times a positive 7 is plus 14. So the way you multiply a binomial times another binomial is you multiply this one times both of these, and then this one times both of those. If you've been around algebra or if you remember it, this is what we call in algebra called the FOIL method. Anytime this process that we just did is what's called the FOIL method. And where it comes from is the letter F stands for the first 2. So if you multiply the first 2 together, this one times this one, you get that. The letter O stands for the outside 2. So the outside 2 would be these 2. The letter I stands for the inside 2. And the letter L stands for the last 2. So first, outside 2, inside 2, and then last 2. Now, I personally, when I'm multiplying it, I don't use the words first, outer, inner, last. I just say multiply this one term times both of these, this one term times both of these. When you do that, you are using the FOIL method. So whether you choose or not choose to use those words is strictly up to you. All right, so let's do some examples by the FOIL method. All right. Oh, and by the way, one other comment, I'm sorry. One other comment. After we did the FOIL method on this one, if you will notice, these two terms right here are like terms. 21x plus 10x, I can add these two together. When I do, that's 31x, not x squared, because you're adding. When you add x's to x's, you get x's. So that is your final answer right there. And you say, well, when you do the FOIL method, will it always simplify further? No, a lot of times it does, but not every time. And I'll show you that in some examples. All right, so let's multiply this one right here. 4x plus 5 times x plus 9. Now, I don't have to say multiply. Here's why. Read the problem. 4x plus 5 times x plus 9. So I don't have to say multiply these two together. When you look at that problem and read it to yourself, it means multiply because there's no sign here. Now, you can't do anything in here, can't do anything here, but you can still multiply these two terms times these two terms. All right, so we have a binomial times a binomial. So this is where we use the word FOIL if you wanted to use it here. We multiply this by the FOIL method. So when you do 4x times this, you get 4x squared, adding exponents. 4x times 9, 36x. 5 times x is 5x, and 5 times 9 is 45. But this simplifies to this because you can add these two together. All right, so on this next one, I want you to copy it, pause the video after you copy it, and work it yourself, and then we'll work it together. All right, so write this one down and pause the video and try to work it out, and then we'll work it together. Okay, you should have already worked this one, so let's see how you did. So we've got, this is multiplication, binomial times another binomial. 2x times 3x is 6x squared, adding exponents. 2x times plus 5 is plus 10x. Negative 3 times a negative 7 times a positive 3 is a negative 21x. And then negative 7 times a plus 5 is negative 35. But you can add these two together because they're both like terms to give you that trinomial. So we multiplied a binomial times a binomial, and we got a trinomial. And that's usually the case, but not always. All right, pause the video on this one now and work it out. Okay, let's see how you did. So we've got 6x squared minus 9x minus 8x plus 12. I can add these together to get minus 17x. All right, let's do another one. Pause the video now and work this one. All right, let's see how you did. You say, well, this one's different. No, it's not, because it's still a binomial times another binomial. So it's still the FOIL method. So it's still the same process. So 2x2 times 3x1 would be 6x3. Okay, be 6x3. Then 2x2 times negative 4 would be negative 8, x2, y2. You could write it y2, x2, same thing. Negative 5y times a positive 3x would be negative 15, xy. And then negative 5y times negative 4 would be plus 20, y3. All of these terms are different. So in this case, none of that adds or subtracts together. So that is the final answer to that problem. Okay? Let's do another one here. Still multiplying. Okay, so pause the video and write this one down. Okay, now this one is a little different. The process is not different, but it's a little longer. Let me read it out loud first. 2x minus 3, binomial, times 5x squared minus x minus 2. So this is 2 terms times 3 terms. Now we don't use the word FOIL anymore. It's not appropriate because the word FOIL is only fits when it's 2 terms times 2 terms only. But it's still the same process, just a little longer. So what I'm going to do now is come to this first term, and I'm going to multiply it times all 3 of these. So I'm going to do this one times this one, this one times this one, this one times this one. Then after I do that, I'm going to do this one times this one times this one, this one times this one. All right. I'm going to uncover the next line, pause the video and copy it, and then I'll show you where it comes from. So pause the video now and copy. Okay, you should have this copied. Now let's see where it comes from. 2x times 5x2 is 10x3, adding exponents. 2x times negative 1x is negative 2x2, adding exponents. And then 2x times negative 2 is negative 4x. Now multiply with the 3. But when you do, don't forget that this 3 is negative. So it's negative 3 times 5 is negative 15x2. Negative 3 times negative 1x is plus 3x. And negative 3 times negative 2 is plus 6. All right, now there's all the multiplying is done. Now it's nothing but adding and subtracting. So to add or subtract, you have to add or subtract like terms. So 10x3, there's no other x3s, put it first. Negative 2x2 minus 15x2 would be minus 17, stays x2. Negative 4x plus 3x is negative 1x, and then bring down the plus 6. And so those 4 terms there, that is your answer. Okay, so that completes the section 5.1 video part 1. We're still in 5.4. We will now go to section 5.1 video part 2.